If you're watching this video on YouTube, you can watch on 1.5x speed.
This is Expert Honda and you are watching Leetcode today questions. Okay, so let's understand today question. Today we have given this question 909 snake and ladder. So let's read the question. You are given n cross n matrix board where the cells are labeled from 1 to n square in a Bostro-Fedon style. Okay, so starting from the bottom left of the board, board n minus 1 0 is the we have, and alternating direction each row. Correct. So it is saying that we have 1 to n square level we have given, right? And then cells, like if the cells we have like this, if this is 3 we have, right? 3, let's suppose we have n equal to 3, right? So maximum it will be become n square means n square means 9. So if we consider like this, so this will look like this one. Okay, 9 square should be here, 9 square should be here. So total 9 values should be there in the uh, in this matrix board. Okay, now it is saying that uh, Bostro-Fedon style, starting from the bottom left and of the board and alternating direction each row. It is saying that we will start from bottom left here. This is the bottom left of the board, right? Bottom left of the board. We will start from here and then we will move to each direction, right? Either we will go to this direction, this, either we will go this, either we will go this, either we will go this. These are the possibility we have, right? These are the possibility we have, correct? So saying you start on square 1, right? We will start from square 1 on the board and we will move starting from square current, starting from the square current, and do the following. First of all, choose a destination square next. First of all, we will choose the destination square next. We are at current. We will move to current destination, and with the level in the range of current plus 1 is minimum. Which one is minimum? Current plus 6 and n square, right? So if we have current, let's suppose we are here, we are at here, right? And we want to move to any other position, right? Let's see this position or any other position, maximum this position. Okay, so maximum can be current plus 6, current plus 6 and then n square it should be, right? Which one is minimum? Obviously it should be minimum this one, right? Current plus 6 should be the minimum, and if that is not the case, so it will be maximum n square at that position. Let's suppose this choice simulate the result of the standard 6-sided edge roll is die roll, and there are always most 6 destinations, and regardless of the size of the board. So if the next has a snake or ladder, you must move to the destination of the snake or ladder, right? Otherwise you move to the next. The game ends when you reach the square and square. Are getting? So it is saying if we are starting from here, right, and we are moving to any 6 results can be possible, right? That is possible. So there are almost 6 destinations we have, and for that, if you'll move to the if the next we reach the next, right? Second point, I'm reading the second point. Okay, if this second point is saying if you if next has a snake or ladder, so that is the destination you will get. Either you, if that is a snake, so you will come to its tail, right? Otherwise you go to the ladder, you will reach to the uh, a destination more than that, and you will you have to move to the next, and so that you may reach to what result, that is n square, that can be possible, correct? Then when you reach the n square, it means game is over. Now let's read the question. A board square row R and column C has a snake or ladder, that is board R and C not equal to -1. Getting? So if board have row, another is a column, and which is not equal to -1, right? If board is this board has given and row column has given, right? And if has a snake or ladder, right? So there will not be value, that not be value, and it is not equal to -1, correct? So destination of the snake or ladder is the board or R and C, correct? So square 1 and n square do not have a snake or ladder. The first and the last two destination don't have ladder and snakes, correct? Only you not you take you only take a snake ladder, or at most once per move. Per move, either one will take either a snake or a ladder. One of the choice we have. If the destination of the snake or ladder is the start of the another stack, snake or ladder, you do nothing following a subsequent snake or ladder. For example, we have board 1 minus 1 4 minus 1 3. On the move, first move, you have to reach to your destination is 2, and follow the square or ladder, that is 3, and but do not follow to the subsequent ladder. Correct? What is saying? For example, if suppose you have given minus 1 and 4, minus 1 and 3, correct? So on the first move, your first destination is what? We will, if we'll start from here, right? So we will reach to what? Next one, right? So your first move, a square is, let's suppose 2, right? First, on the first move, your destination you reach to 2, right? Means we have started from here and we reached to 2, suppose. So you follow the lateral square. If you follow the lateral square, so you are at 3, let's suppose, right? So but do not follow the subsequent letter 4. So you cannot follow this one. From here you cannot follow, correct? Because we have already followed this one. First move we have already done. So we have to return the number of moves required to the reach the n square, right? How many moves we have to, at least minimum number of moves we have to make to reach the n square last position. It is not impossible to reach, then we will return minus 1. I think you have understood. So let's suppose we are here, right? So we have given one example, this one, and it is saying that we have board, right? So we don't have given any n square and those things, right? So let's suppose how many rows we have. 1 rows we have, 2 rows we have, 3, 4, 5 and 6. Total 6 rows we have given, right? So it should be it is how many? 6 into 6 would be there, right? It is about 36. Yeah, 36. You see, we are starting from 1 and we will reach to 36, correct? So total number of row we have given 6, right? So total cells is 36, correct? Now it is saying first we will start from let's suppose 1, correct? So in the expansion it is saying that in the beginning you start at a square 1. So we are starting from a square 1, right? So at row 5 and column, at row 5 and column what, so let me mark this. So if I'll say row 1 2 3 4 5 6, correct, we can say, but we have to we have to count from up, right? So this is not 6. 1 2 3 4 5 6, now correct. So our fifth row is this one, suppose, okay. So at row 5 and column 0 means we are at this position, correct? We are at this position, suppose. So what will happen? You decide to move the square. We are at a square. We are at a square 1, suppose, right? And what is saying? You decide to move the square 2, right? A square 2, and must take a ladder. This one, right? So if we will move to here, right? Here, right? And then we will got what? We will got our this one. Actually, don't confuse. I have started with 0, so it will be 1 2 3 4 and 5. This is the row, sorry. Okay, we have to consider this row 0 to 5, correct? So that's why we are getting here this one. This is matrix, right? Matrix we will start from 0 to n, and 0 to n minus 1 actually. So 0 to 5 will go. So that's why we are getting this row. Now it is saying we are at column 0 and row 5. So we are here. So when we will come to here, second position, right? We must take ladder or this one. If we will take the ladder, right, we will reach to what? 15, correct? Now then we have to decide after 15 if we will reach to what? 17, then what will happen? We will come back to this 13, correct? So after that what we have to decide? We will take the ladder, right? If we will take this ladder, we will reach to what? 35, right? So after taking the 35 we will reach to 36, this one, correct? Next move, after the next move, and then the game is over. So in this, how many we have taken decision? So first we have taken 1 to 2, the one we have. After that we have reached 15, right? We have taken 15, so we'll next move we will take in here to reach the 17. After 17 we have came back to here, what, as 13, and after 13 we will take one move here and we'll take to 14. After that 14, right? So let's suppose it is 3, third move, right? Now we will have reached to here 35. In the fourth move we are completing the game, right? So total count we have taken, total steps we have taken, and that is we are getting 4, right? Number getting 4. Code we have given. So what we'll do here, first of all we find the cell, and then we try to add that on each level, right? 1 to n square. We have given n, right? We have given how many rows we have given. Let's suppose we have given 3. So it will, how many cells will be there? N 3 into 3, right? 1 to n square. And so that what we will do, we will start from the bottom left, right cell, and then we will traverse the board. Alternately we will reach to the left to right, and right to left, you can say. So once we do this by maintaining the order of the column, we will reverse it after each row, correct? After each row we'll do, first we will go like this, then we will move like this, right? Reverse. So we will do that, right? So let's go and do it, right? So first of all we should take the size, what size we have given. So how we'll get that? We have our board, right? This board is given. So see, this board is given. After that what we will do, we will calculate its length, right? Like this. We have got the length of the board. Now to maintain the queue, right, what we have to do, we have to create one cells, right? And then we will uh, take the array to store the distance from each cells from let's say first one to next one, right? Because by distance to the cell we mean at least number of moves required from the source to destination, right? That we will calculate. So the distance from the first cell is itself is 0, right? We will do, and then we mark all the cells are initially unreachable from the first one, right? We will not go first again. And so why we have to do, because we denote the distance of such cell is -1. So we'll push the cells first cell to the queue, and then we will move to next, right? So how we'll do that? First of all we'll take let's suppose we'll create one what we will take, we can take one pair, right? And then we will do the implementation, right? So if I'll take, let's suppose we have a pair of, what, uh, two cells, right? Two cells, integer, and then we'll take integer, right? Two things we have. So this is nothing but our, what, our array. Okay, so this is array type we have, right? Each cells contain the pair, right? And so this is called cells, right? Our board cells, you can say this is our board cells we have. And so we'll take new and we'll say pair. Okay, first of all we'll take its size into n, it will start from n into n, right? So I'll take +1 for one more extra element if you want to store. So we will take like this. Okay, next what we should do, this cells is done. Now what we should do, we will make the level, right? So we'll start from level 1. So we'll take level equal to 1. We have initialized from 1 only. Okay, now we have to take each column, right? Let's suppose I'll take integer of what, row. It's a type of row. So I'll take column, this is column array, and we columns, you can say columns, cells column, you can say, right? You will remember cells underscore column. So each cells column will have what, this is array, like this, integer, and then we'll say this is a size, right? So size will be how many columns should be there, n columns should be there. We have n into n, n into n, like we are talking about 3 into 3, right? If n is 3, so 3 into 3 means what, we have 3 column and 3 rows, right? That's why we are getting. Let me remove this one. Now what we should do, we will assign a default value for each columns, right? How we'll do that? For sorry, let me go here only. We'll make a for loop. We'll start from I equal to 0, right? And go to its length. I should be less than n and I plus plus. Then what we have, column we have, so each column we have column, this column, so each column we have to update by its value. So these are our columns. Now what we have to do for cell, right, we have to increment its pair, right, each time. So how we'll do that? Not here, we can do here also, but after assigning we'll do that, right? So we'll take another loop and we'll take this row will start from what? This row should start from last n minus we have n is the number of node, number of row, n minus 1. We'll start from last row because leftmost, bottom leftmost, right? So we'll start from n minus 1 means the last row. If we have, let's suppose we have 6 n into n, sorry, n is what, n was what, 3, right? So how many rows was there? Total 3 rows were there. So rows are how we have rows like in our example, first example we have given 6, right? So total n cross n cells was there, right? N cross n cells was there, right? N into n, and that is come about, that came around 36, correct? So we have to come to bottom last, right? The bottom leftmost, right, left, that we will start from there. And so that's why we'll say first we have to come to that row, right? First we have to come to that row, and then we will do the calculation, right? The 0, you can say the starting is starting from what, first row, right? 0 row, and that's why we are taking, we'll take from n minus, we'll start from n minus 1 and then we will start doing that. Okay, so n minus 1 we have the row, and then we will do what, row should be, we will decrement the row less than equal to, greater than equal to 0, and then we'll do row minus minus, row minus minus, like this. Okay, so I'll move this one from here. Then what we should do, for each column we'll have our column, we'll take int call, we'll take, and this column should be coming from what we have, column we have, right? Cells column we have taken already, right? Yeah, cells column. From there we will get our each column. Okay, so each column is coming from here, let's suppose. So what we should do now, we should take as it, we have to update our cells, right? Let's suppose we have cells, we have given, we have not cells, right? So cells we have given, right? So each cell we have to update its level after going to, let's suppose we have level plus plus we are getting, and each level we are adding a new pair, right? So I'll take like this, I'll pass one row and pass one column, correct? Row and column we have passed here. Now what we should do, after completing for all the columns we have our cells, right? So we will do, after that we will go back to reverse, right? First we are going to what, G1 to next one, right? 1 2 3, right? Next time what we will doing, we are coming back from what, 4 3 4 5 6, but we are coming from here, 4 will be here, not here, right? Like this, first we'll go to 4, then it will come to 5, then it come to 6, like this. Next row will be look like this one, right? So from we will start from ground to up, right? Bottom to up. And for that what we have to do, there is a collections, right? And collections can be reverse, you can call collection can be reverse, this one, and this method will pass up a what, the list, right? So we'll take in the arrays dot as list, will convert into a list, and then we will pass our given column, this one, correct? This is done. Now what we will do, after completing this one, we will take a list of destinations, right? Okay, so let's suppose we have array, and this is our distances, right? We have distances, right? And that is nothing but int, and we'll take n into n, and we'll take 1 plus for the memory purpose, we'll start from there. So this is our array, right? So we have did n plus n into n plus 1. We are incrementing one length, right? And they will say that we have to fill all the length by what? Its value. Let's suppose we have arrays and we want to fill this value, array dot fill, and then we will pass with what? Default value, right, of the distances where we have created, and all columns, all cells, you can say, we are passing with the default value. If we don't have ladder and snakes, right, that will come. So by default we don't have anything. Now what we will do, we'll create one queue, right? So we'll take one queue and we'll say this is our queue, and this will take what? Integer, and this is nothing but our queue, right? So this queue will take new linked list will take, right, linked list, the last one, and this will take what? Integer, like this. Now at first we know that the distance, first what we have is, by default we are not going to take any other than 0, right? Initial value of first cell, the distance, you can say, is what? 1, 0. We are not taking any, we are not going from here, we are not coming from, we are starting from there. That's why we have to take 0. Now we have q, so this q we will add onto that, this one, this value 1 we have added. Okay, now q have the data, while q have, right, if q doesn't empty, so not, we'll say this is our q dot is empty is a method. So we'll check if not empty, then we will, what we will do, we'll remove from the queue, right? So remove, will, there is a method remove, we'll remove this. So I'm considering each cell as a node. So see, I'll take this as a current node, current cell you can say, or node you can say. I'll say current node because I'm doing BFS, right? So current node at the cell, right? Each cell, you can say, each cell can be considered as, each cell can be considered as node, right? So I'm considering this one. Now what will happen after this, we can move to how many, right, 6, right? We will go to, we will from current to, we'll move to 6 minimum, right? So what we'll do here, we'll consider there is a minimum function, right? We'll take math dot mean, right? There was a math dot mean that was given, and it was saying from the current node, plus current node plus 6, it was saying, right? From the current node plus 6 and n into n, remember, sorry, n into n, the last n is 6, you can say, right? Which one is minimum, so it's a mean distance, mean underscore distance I'll take. So minimum he can take this one, I'll take this as a integer only, this one. He can go this one, maximum, minimum, right? We have to take this move on for the next, right? I'll say minimum, this is our minimum distance take from current node to next node, right? He can go to either next one or he can go to maximum 6, right? So we'll take from there, right? Now we are here, right? So we'll take a for loop, right? And from the current, right, this is our what? Nothing but our current, right? So I'll start from, we'll take one integer I, and this I is nothing but our next node, right? So I'll say this next node to reach, right? Next node, what I will take, So if this is our 0, if we'll start from our 0, then we will move to what? Minimum 1 we have to add, right, in that. So we are not at the current, we are at the current node, right? So we'll say current node plus what? 1, correct? At least one move we have to take for the next, right? That we have done. Now this next node should go to what? Less than equal to the minimum distance we can take, right? Will not go to the n square directly. So minimum is less than equal to this one. Which one is minimum? From the current and the n square n, right? That will come, till that we can go. And then we'll move to what? Its next node. Similarly we'll move to next node. So we'll do plus plus. That is done. So this part is done. Now what we have to do? For each row we have to uh, get the cells value, right? So how we'll do that? Let's see. I'll take one row. Yeah, also I'll say this is board B for sorry B row, board row, right? This is a board row. So board row will start from what? The cells, right? And this is our, we have given already. We have cells, and cells at what? Next node, right? Cells at next node is what we have given. If that is a snake, right? If that is a snake, or that is a ladder, so we'll do get from, if we'll call, there is a method, right? Next node will pass, and then we should this cells is what? Pair, right? Here, right? So cells we have taken like this, right? So I'll pass what? Cells we have given, right? The cells is given cells at next node what we have, and then we will call get, that is not coming, get key. Let's suppose we have get key is a method, right? And then we will take int b underscore column, what we have? Cells we have, then we'll pass next node, and then we will pass get value, not coming this. So we can do this, right? Two things we have done, right? Two things we have done. For each cells we are getting what? Its value we are getting, right? So we have to pass this value. Okay, so what we have to do? For each cell, what we will do? We should pass now we have come to our, we will get our cells and this one, right? Now we have to find the destination, right? So how we'll find this? Let's suppose we have a variable. We'll take our distance, like distance, or either what we will do, I will take our destination to reach, right? This is our destination, and this destination will take our board. We have given board, and this board have row, this row that we have got, and we have column, correct? So either we can pass directly this here, or we will use this one. You can make the shortcut, that is not possible. Leave it. So what we will do? Not equal to, we'll start from -1. If not equal to -1, then this is the value. If we are getting -1, right, then what we will do? We'll go to the board. We have this board, right? If this board not have -1, right? Sorry, -1, or board contains what? Some value that will come. If not have the -1, if don't have the, if not minus, if this is -1, so what we have next node value that will pass, right? So this our destination value, destination node, you can say. So this is our destination node, right? Let me write full destination node. This is our destination node. We will get, right? So next, if don't have a snake site, means we will take that -1. If we have, then we will pass the board value. Now this is done. Then what we will do? We will make a condition and we'll say destination we have given, right? So this destination at dist we will take. We have distances, right? So at distances, what I'll pass, I will pass this one, suppose, and we'll check if equal to -1. Maybe the next destination that we are going, there may be a snake, right? First snake came, then second snake can be possible, right? So we'll go there, and then we will take this distance alag that we have taken. If after when snake will bite, so we are going to its tail, suppose, right? So if that is not a snake, then we will come to here, right? Now what we will do, this position we have to update, like what? This is now nothing but our current value, current node. So current node will get, and then we'll do +1. If that is not the case, if we have -1, means we don't have snake there after coming to the destination, right? We have come to from 17 to 13. If 13 doesn't have a snake, new snake, right? Then what will happen? It will come back again. But we don't have there, so we'll do +1 will do, right? Now what we should do, we'll do q dot after this one, right? We should do always add onto the queue that we have already visited this one. So let's suppose we have queue dot add this and say this is visited now. So destination node we have to pass and be done. Now after coming from here, what we'll do, we will reach to, we'll complete our while loop, correct? After the while loop, we are completing our method. So I'll return here our distance we have, right? Distance we have. So this will surely we have n into n. So we have reached at the there, right? If we are doing that. So let me submit, run this program. So line number 4, we have not taken semicolon. Now we are at row. Here it should be type 2 mistake, so it is row. Now let me run this. Cannot find row and column here. Where? Line number 30. Line number 30. Row we have B row. Yeah. This is our B row. Right. We'll take B underscore row, B row, and B call our board row and board column. That's why I have given the name. This is our column. Yeah, it should work now. Yeah, it will work. Let me submit this. Great. Consistency is the key. See you tomorrow. Great. So let me summarize this one. Okay. So what we have taken here, see, first of all, we have taken what? Our cells, right? And each cells will contain our cell value. So we will take cell column, then we will update its value. What is the cells from 0 to n, right? So we will start with a number of rows, right? The number of columns is the same, and into n. That's why we have updated our cells column. Now what we will do, will for all the row, we'll start from last row, and see, because we are doing right, what bottom left corner will start from there, right? So that's why we are starting from our last row, right? And then we are coming to what here, this one, correct? See, if we have total 5 rows, right? So we'll start from the fifth row, and fifth row we have the first cell, right? So we'll start from the each column. First column will start, right? That's why we are taking the first column. Okay. Now we are doing the we can say initialize our cells, right, with the pair. Each cells contain its pair, right? That's why we are taking. Now we'll do the reverse, right, for the cell for the cells column. After doing that, Now what will happen, we will take a distances, right, array, and we'll update with -1 for its value, right. Then what we'll do, we'll have our you can say queue, right, and all the queue first will start from the index 1, right, index first cell 1, we'll add 1 at that position. So for that distance is 0, right, because this is the first cell, and then we will add on to the queue. After coming to that, if queue is not empty, so we'll do queue dot remove, we'll got the current node, and from the current node we'll take the minimum distance b. So our next node maximum can go what, minimum distance he can go. And after this we'll create next node, right, and after creating the next node we'll create our board row and column value, so that we will check the destination node have the if the board contain -1, then we will move to the next row, next node. Otherwise what we will do, next node is nothing but our board column value and this, right, like that. After that what we'll do, we'll check the distances have -1 at this position, this node, then we will assign +1 by using this value, and otherwise we'll do add on to the queue. Okay, that's all we have. So thank you so much guys, please hit comment, like this video.